essential revision on some of the basics if you haven't met complex numbers before. So first of all, how to plot. What is a complex number and how do we plot that on an Argand diagram? Well, if we look at the first example, Z1, we have a real and imaginary part. The real part is a positive 4 and the imaginary part is a negative 4. So it's shown there. That would be 4 along and 4 down. And that's how we would plot Z1. As indicated there, if we are going to construct an Argand diagram, we should label the axis. The horizontal axis is the real axis and the vertical one is the imaginary axis. Z2, negative 6 plus j. So we plot that by moving to the left by 6 and up by 1. Although in this unit you might not be asked to construct Argand diagrams as part of an exercise or an assessment, later on it is useful to plot the points to help you find angles and magnitudes and just to have a better understanding as to where your complex number actually is. You'll see that later on in some of the later exercises. So on to the second example, solving a quadratic equation. We're given here x squared minus 4x plus 8 is equal to 0. So normally we would attempt to factorise this, and if we found it didn't factorise we would use the quadratic formula, and the reminder is given there in the top right hand corner. So we'll substitute the numbers in to the quadratic formula. So we're substituting in the values for a, b and c. And normally underneath the square root sign there we would end up with a positive number and we'd be able to take the square root of the positive number. But in this case, when we calculate what we call the discriminant, we end up with negative 16. Now if you try to punch it into your calculator, we cannot get the square root of negative 16. So this is a reason, one example of the use of complex numbers. It helps us to solve a quadratic equation that otherwise we wouldn't be able to solve. So showing all the actual steps here, we break down in the square root of negative 16 into two parts. Now we wouldn't normally do this. You wouldn't normally show this step perhaps from now on, but just as a means of explaining what's going on here. So negative 16 is made up of 16 times negative 1. Now you know the square root of 16, that's 4, but what is the square root of negative 1? Well, we assign this a letter. The square root of negative 1 is equal to j, and that's something that you just have to remember. This gives us a final answer. We have the square root of 16 is 4 and the square root of negative 1 is j, so we have 4 plus or minus j4 over 2. And if we tidy that up, simply dividing the top line by 2, our final answer consists of, we have two answers, we have two solutions, and both are complex numbers consisting of a real and imaginary part. So the solution to this quadratic equation is 2 plus j2 and 2 minus j2. Here's another example just to help illustrate this. Again, a reminder of the quadratic equation in the corner. Again, this doesn't factorise, so we have to use the quadratic formula. Substituting the numbers in. And this looks slightly more awkward because it didn't come out as whole numbers at the end. We've ended up with fractions. So again here the discriminant, when we calculated it, turned out to be negative 100. And I've stopped showing some of the working here. The square root of negative 100 consists of the square root of negative 1 times the square root of 100. Of course the square root of 100 is 10. So we have 2 plus or minus j10 over 4, and if we tidy that up, the final answer is we have two answers, a half plus j 5 over 2 and a half minus j 5 over 2. So we now have some practice questions for you to try. 4 questions given there. The solutions are on the next page, so you can stop the video now or press pause and have a go at these. Okay, here are the solutions. Not every single step shown, but the essential steps are shown there, so it gives you a chance to check if you've got these correct. Okay, example 3. We're adding or subtracting some complex numbers. So part A, z1 plus z2. Fairly straightforward. We gather together the real parts, so 2 plus 3 is 5. And we gather together the imaginary parts, so we have j8 plus negative j, so that's 8 take away 1, giving us j7. Part B, we initially multiply z2 by 3, so 3 minus j becomes 9 minus 3j, and z3, which is originally 5 plus j4, we need to multiply that by 5, so we have 25 plus j4. So to begin with, we need to set that one up. Now we can subtract. 9 take away 25 is negative 16, and minus 3 subtract another 20 is negative j23. Example 4, remember that j is the square root of negative 1, so therefore j squared is minus 1. So going to multiply some very straightforward complex numbers. If we have j3 and we're multiplying it by 8, it's simply j24. Slightly trickier, j2 times j3. Well, the 2 times the 3 gives us 6, but the j times the j gives us j squared. But as we say at the top of the page there, j squared is negative 1, so the final answer is negative 6. So need to take care when j times j appears in your solution, because you're going to have a j squared, and that itself is going to be equal to negative 1. So these ideas are going to follow on in a minute in the next examples. Okay, here we have two complex numbers that have real and imaginary parts. So let's initially multiply the brackets. 1 times 3 is 3, 1 times negative j4 is negative j4, and we have a positive j2 times 3 giving us plus j6, and the term at the end is a positive j2 multiplied by a negative j4. So 2 times 4 is 8, and a positive times a negative is a negative. On the next line, I've tidied up the j squared term. J squared is negative 1, but we have a negative, so therefore we have a negative times a negative giving us a positive. Final answer is 3 plus 8. Gather together the real parts to get 11, and we tidy up the parts in the middle there to get plus 2. Part D is just the same. It's just to say, look, if we have brackets squared, we're just multiplying it by itself. So we have 4 minus j3 times 4 minus j3. So 4 4s are 16, etc. And the only slight difference here is because we had two negatives that give us a positive j squared. So j squared is negative 1, so a positive times a negative is still a negative, so we have 16 take away 9 giving us a 7. So that's that one completed. So worksheets 1 and 2, both worksheets can now be completed.